Hello friends, welcome back to my channel. In this tutorial I am going to show you how to render flip fluid in Karma XPU inside Houdini. So let's jump inside Houdini. We'll start with the view folder. We call it our flip object. Take a sphere. Make it polygon, increase the frequency to 10. Now take a mountain node, mountain, and now translate it in y direction. I will take a transform and translate it to 4. And its scale to 0.5 and add a null. We'll call it emitter. I will change my display to dark mode. And I will change display particle size to pixels, uncheck display sprites. Now make another view folder. This is for our collision object. Go inside and import my 3D model. I have modeled this glass and I will scale it to 1.5. My emitter is very near, so I will translate it to 5. Okay, this is better. And make a null. We'll call it our collider. And for our simulation I will create .NET and name it simulation. Go inside and take a flip object, a flip solver, a gravity, and a volume source. Now connect flip object to first input and volume source to last input, and flip solver to gravity and gravity to output. Now you can see our bounding box is very big, so resize it. Select flip solver and go to volume motion and box size, resize it to 5 by 5 and in y direction it 7. Now our emitter is outside of the box. So I will transform my box to 3.5. Now you can see our collision object and emitter both are inside, and select flip object and remove this subpath and select our emitter and make particle separation to 0.03 and check close boundaries. Now select volume source and in subpath again select our emitter and in particles tab check source particles and from group remove this particles. Okay, let's check our simulation. It's not working properly because our flip fluid is not colliding with our collider. So go to object level and select our collision object and go to collision and click on static object. Now go inside flip object, in collision object, and here this file cache node I don't need it, so I will delete and make another null, name it to glass and make display flag on and select collision source, go to volume and make voxel size to 0.005 and bandwidth to 16. Now check again. Now you can see some of the particles are going outside from the glass, so we have to fix it. Now go to our simulation and select collision object, which is static object, and go to collision tab and in collision detection use solver default to use volume collision. Okay, let's check again. It's not working and we have to fix our sub steps. Go to flip solver and sub steps to minimum 4 and maximum 4. Let's check again. This is better than before, but I will increase minimum to 6 and maximum to 8 and check again. Now this is very better than before, so I will stop this and go to object level and make another geo folder we call it catch. I will take a .io and select my DOP network, which is simulation, and in presets choose flip fluid, and I will add a file cache to catch my simulation or particles to my disk. On my desktop, create a new folder, call it catch, and name it to particles catch. And save it to my disk. Now our particle sketching is done, and rename it to particle sketch. And connect a particle fluid surface node, and disconnect this .io. In particle fluid surface, I will change my particle separation. It will be same which is in our simulation flip object 0.03. so I will copy parameter, and in particle fluid surface paste here its relative reference, and I will change its influence scale to 5 and droplet scale to 0.75 and adaptivity to 0, and convert to surface polygon. Now check this, go to object level and make display flag off on simulation. Now you can see how our mesh will look like. Go to catch and make a droplet scale to 1 again, so it will be thick, and influence scale to 3 or 4. Now this is okay, and for our meshing I will create another file cache. We call it meshing, and again I will save it to my disk. In my cache folder, make a new folder, mesh, and file name to meshing, and save it to my disk again. Now our meshing is done. Now we can see our meshing in real time. This is looking so good. Now add a null We call it our flip fluid mesh. Now go to object level again and add another geo folder. We call it render. Take object merge and select our flip fluid mesh from cache folder. And display flag on from here, and go to render, make a null again. This will be our render flip. Now select a camera for this and change the resolution 1280 by 180 and lock this camera. And add an environment light. And from environment map I will select my HDRI. I have downloaded it from internet. Now go to stage tab and import our scene. And select our camera and change Houdini GL to Karma. Now you can see our mesh and collision object both are in the scene, but we have to change its material. So I will add material, connect a material library node, go inside and check material X. Standard surface. Sorry, this material X standard surface, rename it to liquid, and again take another material X, so I will copy it and rename it to glass. Now select liquid and change the base to 0 and color to black, and in specular to 1, specular color white, transmission to 1. Now change our material or glass color to something like dark gray, and specular to 1, transmission I will not change, metalness to 0.75. Now assign these materials to my objects. Now I will add assign material node and the number of materials to 2. Remove this and select our mesh, and again in second we have to select our glass, and in material for our mesh select material liquid, and in material path of our collision object select material glass. Now you can see materials in the viewport. Now add a karma render properties, and change its resolution to 1080, and you can see rendering engine is CPU, and you can change it to XPU. It's working because we have used material X, which is supported by Karma XPU. Now for rendering fast, go to image input, filters. If you have NVIDIA card, you can select NVIDIA optics denoiser and make a pixel samples to 64. Now you can see our liquid. You can render it fastly by Karma XPU. And render it out by taking Karma and here you have to select again Karma XPU and make a resolution to 1080 and change the pixel samples to 64 or more, and in image output select filters, and also you can choose NVIDIA optics denoiser if you have NVIDIA card. Otherwise you can select Intel Houdini and select your path to render this from output and click on render to disk. Thanks for watching.